What you think? Let's be different today. There we go. Okay. And we'll start from current slide. And I did finally see I think for sure, if my memory is still here, that the math club, and y'all are all very much potential members of the math club, math team, some of you especially, but it meets on Friday. I believe it's Friday mornings from 9:30 to 10:30 on the Birmingham West Campus in the Science Building, which is the C Hall, and I think C100. Ms. Gerasi is the coach for that, and I have had students participate in that. One was a calculus student who came in deer in the headlights scared of calculus. You know, it'd been a long time since he'd been in school and stuff like that. He was on the math team, and soon he was the one answering questions like crazy. He overcame a lot of fear and really enjoys math, and it's just, it can be very beneficial as well as a lot of fun. So please consider contacting Ms. Gerasi or just showing up on a Friday morning, 9:30 C100 Birmingham West Campus. Okay, trying to think if there's any other announcement. Oh yeah, so I forgot to bring the sheet in. Next week is Cougar Connection Week. And that means that there's activities going on just about all week, Monday through Thursday anyway. On Monday there is I guess sometime next week is Constitution Day. I wasn't aware that there was one, but I guess there is Constitution Day. There will be a program on this campus. I believe it's 12 to 1 on Monday. On the Birmingham campus, if y'all are over there, they have basically sign up, get involved for any kind of volunteer work you might want to do. There's going to be a ton of organizations there that you can volunteer with, or campus organizations you can become a part of. So lots of opportunity there on that campus. On Tuesday, they flip-flop. They have the Constitution Day presentation. We have the sign-up for volunteer and campus organizations. So if you are over there, you can do it here on Tuesday. Then on Wednesday, I know there's something going on both campuses, and I think it's the same program, just at either different times or same time, different people will be presenting it. So watch for that. There's posters all over the walls and doors and various things, so look at it. The copy I have is so small I have to squint to read it. So check that out. That will be Wednesday. Thursday, just about all the activities on the Birmingham campus, including, in the evening, a pool party in the Arthur Shores Fine Arts Building. That's where our pool is. That's where our gym is, in the Fine Arts Building. Makes sense? Okay? And it's an indoor pool, great facility, and you don't have to get in the pool if you don't want to, but it'll be a good pool party anyway. And that's, I think, going 4 to 6 or something like that on Thursday. I think that wraps it up. And sometime next week, they had originally scheduled, I don't know for certain if it's going to happen, a blood drive. So watch for that too. When I was basically about your age, I started giving blood with the Red Cross and never stopped until I found out I had leukemia. So they said, no, we don't want yours anymore, but for years and years. And it's one of the most easiest thing you can do and can give life to people. So how can you beat that? All right. Any questions on anything we've done so far or anything else? Okay. Then we're going to talk about even and odd functions. So we have a few odd functions in here, I think. Never mind. We'll talk about even and odd. You've studied different types of symmetry of a graph. If you haven't studied it, you probably noticed it. This one does this and that, it seems symmetric in some way. Or this and then that, seems symmetric. In the terminology of functions, a function is said to be even when the graph is symmetric with respect to the y-axis. The y-axis, vertical axis right down the middle. And if a function does this on this side and does exactly the same thing on the opposite side, then that's called an even function. And I mean forever. They continue doing that as no matter what x you choose. Whereas if it's an odd, whoa, I can't do that. Okay, can't touch that. Okay, when the graph, and is odd, okay, when it's symmetric with respect to the origin. Well, what does that mean? Well, if the function is doing this, then it does this on the other side. Or if it does this on this side, it does that on the other side. It goes in exactly the opposite direction forever. Okay? Those are the two things. Now, once you get into trigonometry, which I hope all of you or most of you do, I doubt you will, but I hope you do. Great topics. Next course after this, Math 113, you'll find that every one of the trig functions is either even or odd. Okay? And there are certain functions that are like that. But of the functions we deal with on a day-to-day basis in this course, they've left out the biggest category. Can I get your name, please? Yeah. Okay. All right. And that biggest category is, anyone want to hazard a guess? Neither. Okay? Neither even nor odd. A lot of functions do various things on either side and aren't particularly consistent with it. Okay? So, they left that one off, but that's the biggest. The symmetry tests yield the following tests for even and oddness. That thing that we're just talking about, let's see what that means. If you go to the right on x and you find a y value, if you go to the left on x, the same amount, and get the same y value, that's an even function, right? But if you, and that's no matter what x you go, it's always going to be the same, wherever it is. But if it's an odd function, if you go to the right and find it here, when you go to the left, same amount, you'll find it exactly opposite of it, no matter where it goes and how far it goes. So, guess what? A function f of x is even when, for each x in the domain, whichever x, how far out you go there, each x in the domain of f of minus x is the same as f of x. F of minus x is the same as f of x. Same value, those are even functions. Okay? Whereas the function y is equal to f of x is odd when for every x in that domain, f of minus x is exactly the opposite of f of x, no matter where you go in the domain. Okay, how many tests is that? 1 or 2? 3? 7? It's only 1. Guess what? All you're looking at is f of minus x. Same thing for either one. Just instead of x, plug in a minus x. Evaluate the function. Then you see, is it the same function? Is it the opposite function? Or is it neither? Okay? Frankly, you'll see a lot of neithers. Okay? If you're looking at an even distribution of things. So let's do one. And I hate they already have done the problem for you, so I'm going to cover it as well as I can. Let's not even worry about that. What? Ow! Yeah. What would you do to that? To test whether it's even or odd. Oh, they've already told you too much there, too. Okay. What would you do? They told you what it is. Sorry, I can't cover everything here. Can I get your name, please? Huh? Tiana. Okay. Oh, really. Yeah. Good deal. Does anyone else come in? I didn't catch you when you came in and get your mark here. Oh, I can't cover everything. The test is simply, instead of x, put in a minus x. That's your test. Put in a minus x. And when you put in a minus x, this one I will cover. Okay, when you put in a minus x, what does that become? You're reading my hand, aren't you? Never mind. Okay. Go again. Negative x cubed. And then when you put in a minus x for the second term, what do you get? Plus x. Well, guess what? Minus x cubed plus x is exactly opposite that. So g of minus x is the opposite of g of x. Therefore, and they show it here. And I like this room so much. Okay. and that is minus x cubed plus x, like y'all just told me, and that's exactly the opposite of minus x cubed minus x. Do you see that? Exactly the opposite. Therefore, it's an odd function. Make sense? No? What's missing? The test is plug in a minus x instead of x. Evaluate it. Then compare it to the first function. That's what you do. Okay. Any questions? People still writing? Okay. Can I move on? Okay. And that's minus g of x. Sorry. I said it was. They said it was. Okay. And that makes it an odd function. Here's the B one. Okay, what's your test? What's your test? Plug in a negative x instead of x. What happens if you put in a negative x here? You get x squared, because it's negative x, in parentheses, squared. Negative times negative is positive, x times x is x squared. Yeah, okay. Plug in a negative x here. There is no x. It's just a plus 1. So you get x squared plus 1. That's the same as h of x. So h of minus x is the same as h of x. Therefore, it follows that this is what kind of function? Even. Okay? Even Stephen. Let me get your name, please. Ashley, got it. Okay. Is anyone else coming in since the call roll? Okay. Now, so you plug that in, you get x squared plus 1, which is exactly the same as h of x. So if h of minus x is equal to h of x, then it's an even function. Okay? Do they have a C? No, they don't. Shame on them. Okay? So, let me give you a C. Okay? All right? It's not a C, but I'll make up another problem. Let me get my pen situated. All right. F of x is equal to 5 minus 3x. Okay. You're already here. Okay, I got it. Okay, what's our test? Plug in a minus x. So we'll do f of minus x. And that's equal to? Say again?
Negative 5.
Where did you get negative 5? 5 minus 3 times negative x, and that is 5 plus 3x. Is that the same as the first function? No. Is it the opposite of the first function? No. The opposite would be minus 5 plus 3x. Guess what? Nope. Neither. Neither even nor odd. And you'll see lots and lots of functions we deal with will be neither even nor odd. Those two they gave us, the first one was odd, the second one even. Yep, those are nice and fun to have. This one, however, is a neither. Okay. Now, can I cheat a little bit? Okay, wait. Well, it doesn't matter. Here is a... Now, this only works, I would say only, mostly works for a polynomial function. Always works for polynomial functions. Okay? What's the exponent here? What's the exponent here? What do you notice about 3 and 1? They're odd numbers! Look at that! That makes it an odd function. And guess what, team? On this one, what's the exponent here? And what's the exponent here? 0. X to the 0 is 1. No, x to the 0 is 1. Anything to the 0th power is 1, except 0th power is undefined. 17 to the 0th power is 1. Minus 5x cubed to the 0th power is 1, okay? So this is to the 0th power. And guess what's true about 2 and 0? Even. Oh, wow. So it's an even function. Now, what's the power of this one? 0. What's the degree of this one? 1. Guess what? One's even, one's odd. Neither. All right. Cheap way. Don't even have to use a test. But that only works, or mostly works for polynomial functions. In case those people don't want to hear what I'm saying, they'll still hear, but not quite as loud. Okay. So there's another simple little test. Okay. Works for polynomials, though, not guaranteed to work for other functions. All right, any questions on that? Okay. If none, here are graphs of those two that we just did. The first one was g of x was x cubed minus x. Here's how it graphs. Does that look like it's an odd function? Surely is. When it goes down here, it's going up here. When it turns, it turns. When it goes up here, it goes down there. Exactly mirrored across the origin, which they show across this line, which I don't find that particularly helpful, but it is a way to look at it. Whereas this one, here's what they show with the line. When you change the x to a minus x, you change the y to a minus y. Yeah, that's what they're showing here. The line really has not much to do with it. This one, when you change from x to minus x, you keep the same y, which means it's symmetric across the y-axis. This is symmetric across the origin. That's symmetric across the y-axis. Make sense? And your values should be. All right, good deal. Any questions on even and oddness and neitherness? Okay. That's a new word, by the way. Okay. No questions? All right, that was the last slide in section 1.5. Let's move on to, well, let's first do our vocabulary in 1.5. You should have kept that up a little longer. First, this is top of page 56, 1.5 exercises. The blank, blank, blank is used to determine whether a graph represents y as a function of x. Vertical line test, right on the money. Number 2, the blank of a function y is equal to f of x are the values of x for which f of x equals 0. What? The blank of a function y is equal to f of x are the values of x for which f of x is equal to 0. The zeros of the function. Very good. Emphasis intentional. Okay. Number 3. A function f is blank on an interval when, for any x1 and x2 on that interval, as long as x1 is less than x2, that implies that f of x1 is greater than f of x2. What kind of function is that? Decreasing function. Excellent. Number 4. A function value f of a is a relative blank of f when there exists an interval x1 to x2 containing a such that when x1 is less than x2, that implies f of a is always greater than or equal to the other f of x's. A relative maximum. Did someone say it? I imagined I heard it. Okay. Relative maximum. If f of a is always greater than all the other f of x's, or equal to. Number 5. The blank, 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 blank between 2 points, x1 f of x1 and x2 f of x2, is the slope of the line through the 2 points, and that line is called the blank line. Average, what do you say, rate of change, okay? And what's that line called? Secant line, you got it, okay, for 500. Okay, never mind. All right. The function f is blank when for each x in the domain of f of minus x is equal to minus f of x. Oh, odd function, isn't it? Okay. Homework exercises here. Do either 7 or 9. And by the way, since some of you came in after we had this little discussion, I just found out this morning, thanks to Amanda, right? Yeah. That the guy who put out the WebAssign, I called Cengage and said, look, the students say they can't can't see their ebooks even though they paid for them until a thing has been done. And you said, if you need help, call. I'm calling. I don't use WebAssign. This book is so good, I don't see any point in it. But it is a good package. But you had to have that set up. So he said, how do you want them done? I said, I don't care. I'm not going to grade any of them. I'm not going to have them grade it because they get them wrong sometime. So whatever you want to do. Just put some sample problems of every type out there. So as far as I can tell from what you said, he must have put them all out there. And he said, though, they're due by December 9th. Okay, say again? 20, sometime in December, which means the end of the term. Now, does that mean they're due? No, I'm not going to take them up. I don't expect them. But they're out there for you as long as you need them, till the end of the term. Okay? Because final exam, you might need to review that kind of exercise. So they're there for your benefit. Do them. Use the tools, use the tutoring, use anything that they've got there, and they've got some good programs there. Now, sure, they're going to say some right answers are wrong, but I think you can live with that. Just skip to the next one and make sure you're not doing something wrong. It's their problem, not yours. And if you have questions, I'll be glad to answer those questions. Is Alexius? Okay. There you are. All right. So they're out there. Don't worry about due date. All that means is in your mind say available date. They're available till the end of the term. Use them. Okay? So, why did I get off on that? Because it reminded me here, this book has all the extra help you could possibly have, but if you want more, it's there. 7 and 9, I was given the homework exercises. I've given these before, by the way. They're both at calcchat.com, 9's at calcview.com, and guess what? You don't need a code, you don't need anything. Absolutely free, available website for everybody, whether you're in the course or not. They can all see these things. That won't make any sense to them, but it makes sense. Okay. Then do either 11 or 13. They're both at CalcChat. 11's at CalcView. Do any of the odds 15 to 25. They're all at CalcChat. 25's at CalcView. Do any of the odds 27 to 31. They're all at CalcChat. Do any of the odds 33 to 39. They're all at CalcChat. 35's at CalcView. Do any of the odds 41 to 47. They're all at CalcChat. Any of the odds 49 to 53. They're all at CalcChat. 51's at CalcView. Do any of the odds 55 to 59. They're all at CalcChat. 57's at CalcView. Do either 61 or 63 or both. They're both at CalcChat. 61's at CalcView. Then there's an applied problem 65. Try to do that one. Then either 67 or 69. They're both physics type problems. They're both at CalcChat. Then the ones we just did today, any of the odds 71 to 75. They're all at CalcChat. 71's at CalcView. Do any of the odds 77 to 81. They're all at CalcChat. Then, this is sort of some new stuff. I kind of hate it when they do this, but this author has a tendency to do it. Sort of brings up some new material in the problems that you haven't done in the section. It's pretty straightforward and fairly well explained. If you have a problem with it, bring it to class, we'll work them out then. Do 83 if you can, it's at CalcChat, and 85 if you can, that's at CalcChat. I really don't care too much for 87 because it's showing you something that's wrong and saying you find what's wrong with it. That's a decent exercise, but I just hate for you to be looking at something in a math book that you know is wrong. It's going to put it in your brain that You saw it in the math book. Okay, then 89 is at Calc Chat. There's a couple of true false, 91 and 93. They should be at Calc Chat. 95, so think about it, so you can think about doing it if you want to. It's at Calc Chat, should be at Calc Chat as well as 97 is a writing thing, so if you want to do it, you certainly can. It should be at Calc Chat. But 99 is another even and odd situation that might be worth your look, and it should be at Calc Chat as well. Any questions on 1.5? Little less time to do that than it was 1.4, right? Thank goodness. Okay, so let's move on to 1.6. Okay? Now 1.6 is almost a summary review type situation. Not just review. Can I get your name, please? Trees. Okay. I know you're in here. Hey, you're here somewhere. There you are. All right, got it. Okay. We'll start from the current slide. Still in Chapter 1, functions in the graphs. 1.6 is a library of parent functions. These are the ones responsible for the paying the bill. No, these are the functions that the others come from. So here are our objectives. We'll identify and graph linear and squaring functions. Those are two types of parent functions. Identify and graph cubic, square root, and reciprocal function, three other sort of parent-type functions. We'll identify and graph step and other piecewise defined functions, which are not very parent at all, and recognize the graphs of parent functions, which I thought that's what we were doing. Okay, so let's look at first linear and squaring functions. What in the world does the word linear mean? Say again? Okay, yeah, the first four letters in it are L-I-N-E, line. So when you graph this function, it's going to be a straight line. Some kind of straight line, okay? So how about a squaring function? What do you reckon that would be? When something is squared, what is it done to it? Say again? Okay, no, not that kind of square, okay? I know what you're thinking about there. Second, yes, it's a quadratic. You're absolutely right. A squaring function, the maximum, the exponent, the only exponent is a 2, squaring it. A linear function, by the way, okay, if I see the graph, I know it's a linear function, whether it's a straight line or not. But can I look at the equation and know it's a linear function? Yes, how? Okay. I think what you're starting to say, if I heard degree pop out there, the degree of the function is 1. In other words, the maximum exponent is 1. That's going to be a linear function. The only exponent, 2, that's going to be a squaring function. So there, we have what they are already. And one of the goals of this text, the way this guy writes it, is to enable you to recognize the basic shapes of the graphs of different types of functions. So that's why he breaks them down this way. For instance, you know that the graph of a linear function, f of x is equal to ax plus b. And by the way, that's how every linear function is going to look. F of x is equal to ax plus b. Now, what do we normally call a? What's something that every line has? A slope. Okay, so the a is a slope. What is the b? What? Someone said that. Y-intercept. Perfect. Okay? Here it is. From the slope, m is equal to a, and the y-intercept is 0 to b. Now, an intercept is usually a point, right? A point is an ordered pair, two coordinates. And why is this always a 0 there? Well, what is true about a y-intercept? Where do you find all your y-intercepts? on the y-axis. The y-axis is intercepted, is found the function there, okay? And what is true about everything on the y-axis? One of the coordinates for it. The x is always 0. Because you're not going right, which would be positive, left would be negative, x is 0. So guess what? How you find the y-intercept? Put 0 in. Well, let's do that. Put a 0 in for x. And what do we have? What is f of x? Big question. Most important question of the term is y. Y is equal to b. With x equals 0, y is equal to b. That's why it's a y-intercept. Okay. So there's what a linear function is. Now that's not the parent linear function. That's any linear function. Okay? If a was negative, what would that mean? The slope is going downhill. A is positive, uphill. A is 0, yeah, but flat, okay? They're all straight, okay? Flat, okay? Now, I left out this one. What's true about the slope of that one? It has no slope. It's undefined because you're dividing by 0. Can't do that, okay? The change of x would be 0. You can't do y2 minus y1 over 0. Can't happen. So, and by the way, is that a function? Is that a, why not? It fails the vertical line test miserably. These don't have any in it, but every point's on it, okay? So yeah, it fails the vertical line test miserably. All right. The graph of a linear function has the following characteristics. What's the domain of a linear function? All real numbers. All real numbers. Never anything but that. Okay? Now, if m is 0, what's the range of the linear function? B. Okay, that's the only value on it, right? If the m is 0, it's f of x equal b. So that's the only point on it. If it's not 0, what's the range of the function? Say again? Yeah, all y values. All real numbers y will go into the range. M is 0, you only got 1. Otherwise, for a straight line, it goes infinitely that way, or infinitely this way, infinitely that way, as long as that slope's not 0. Okay? So the range is a set of all real numbers. The graph has an x-intercept where? Ooh, that one's strange. What do we mean by x-intercept? Where the line crosses the x-axis. And what's true about every point on the x-axis? Every point on the x-axis. Y is equal to 0. You're absolutely right. And what was our y? Let's go back to this. Here is your f of... Ooh, my pen's not right. Okay. F of x, which is what? What's f of x? Y, yes, that took way too long, is equal to ax plus b. Okay? And what did I say was true about the the x-intercept? Y was equal to 0. So you put a 0 in the y is equal to ax plus b and solve for x. What do you get? Help me. Help me, help me. Subtract b from both sides, and then that gives you ax, because these go to 0, is equal to minus b, divide by a, and guess what you get? X equal minus b over a. And that is called the x-intercept. Minus b over a, comma, 0. Because you always put an intercept as an ordered pair, and the x-intercept is always the y is 0. And that's what they got here. Only now they say b over m, okay? That's fine. Remember, m was equal to a, okay? Minus b over m 0. Would I memorize that? No. I'll just work it out if I ever need to know it, okay? But the y-intercept, that's really easy. What's the y-intercept? 0b, Okay, that's what the y-intercept is, that b, that constant value. Now, tell me about, and you've already answered this question earlier, but just to see if you still remember, what can you tell me about the slope of a linear function? Okay, it's either increasing, decreasing, or constant. Okay, and what determines whether it's increasing, decreasing, or constant? The slope, exactly. If a is, or m is greater than 0, increasing function. If it's less than 0, decreasing function. If it's equal to 0, constant function. All right, make sense? All right. Let's do example 1. Whoa. They're not giving us a linear function. They're saying write the linear function, f, for which f of 1 is equal to 3 and f of 4 is equal to 0. Goodness, what does that tell us? Anyone make a guess of what that tells us? Okay, let me draw a symbolic hint. There, you got it. The x equal 1. When x is equal to 1, because x goes in the parentheses, right? Then the y, which is f, is 3. Okay? And what's the other thing this tells us? This is 4, 0. Okay? That's 2 xy points. Okay? Does that get us any closer to finding a linear function? Tell me what the linear function looks like. You explain it to me. What does it look like in general? F of x is equal to, what's the form of a linear function? Okay, only let's go back to mx plus b. Okay? Y'all okay with that? Okay. What in the world does that m stand for? Slope. We don't know the slope, do we? And there's no way to get the slope, is there? Yes! Slope is, m is equal to, what did you just say? y2 minus y1 over x2 minus x1. And guess what? We got a thing popping in place. We got an x1, y1 and an x2, y2. And which you name them, it doesn't matter. It does not matter. You pick y2. A little bit matters. Pick a y2, any y2. Either of those two y2s. Which one? 0? Okay, that's a good choice. That fixes everything else. What's your y1 then? 3. What's your x2? 4. What's your y2? X1? 1. You see, once you pick that first y, and by the way, the y has to be one of the second numbers. It can't be one of the first numbers. When I first said that, okay. Anyway, what does this yield? Negative 3 over 3, which is negative 1. Okay? Well, we're halfway there to doing our f of x is equal to minus x plus b. We still need to know what b is. Now, any of you have any clue of how to get the b? Second? It certainly is, but I'm not sure I know how to do that. I could draw a graph and probably get it that way. I hate drawing graphs. No, I don't. I didn't say that, did I? Okay, now, how's a way we could do it algebraically? Okay. Now, remind me what f of x is? Y, okay. Do we have a y anywhere on the board? What is it? Okay, pick one up. 0, okay, he likes 0. So let's put in 0 for your y is equal to minus, and what x goes with that y? 4, okay, plus b. That has to be true if that point's on the line, isn't it? You could have chosen the other one too, okay? So guess what this tells us? B is equal to 4. So now we can go back and fill in both blanks. F of x is equal to minus x plus 4. There's the line. Okay? There is the linear function for which that's true. Let's just check and make sure we're telling the truth here. Okay? If you plug in a 1 here, what do you get? Say again, negative 1 plus 4 is 3. Sure enough, that worked. And if you plug in a 4 there, negative 4 plus 4 is 0. Yes, it works. Both of them work. So I'm convinced that is the equation, the linear function for those 2 points. The only one, by the way. If you have 2 points, how many lines can go through those 2 points? 1 and only 1. 1 point, how many can go through it? Infinite number, okay? Can go through 1 point, okay? But 2 points, 1 and only 1. 3 points, they better be in a line, otherwise if they're 3 like this, no line will go through those. So 2 points will give you a line. All right, good deal. Let's clear all my scratch off of there. Anyone need that any longer? Some people still writing. Okay. Is this making sense? Okay? Is it too slow? Okay, it's all right. Okay. Sometimes I think I go too slowly. Okay? Oh, I meant to erase. Let me erase first. Okay. So, to find an equation for a line that passes through these 2 points, well, the equation of a line, of a function, is mx plus b, a linear function. So you need to calculate the m, somehow find the b. M is easy. You have 2 points, we can figure what it is. Just like you told us, okay? And they chose the same y2. You may not believe me. What if we had chosen this to be a y2? 3. What would be in your slope then? 3 minus 0 is 3 over 1 minus 4 is minus 3, and 3 over minus 3 is still minus 1. So it doesn't matter which one you choose, x2 and y2, but once you choose one, you're stuck with the others. Okay. So that's going to be minus 3 over 3, which indeed is minus 1. And here's another way to do it. I gave you one way, here's another way. There is this other form of a line besides slope-intercept, which is what we've been using, mx plus b, and this is called the point-slope formula. Y'all remember this from somewhere in your vague past? Okay? Okay? Y minus y1 is equal to m times x minus x1. And guess what? This shouldn't be that hard to remember. Let me give you why. Remember this? M is equal to y2 minus y1 over x2 minus x1. Now, when do we use that? When we know 2 points and don't know the slope, right? Well, what if we knew 1 point and the slope, but didn't know another point? Well, what we do then is take your eraser and erase the sub 2's, okay? That means that x's and y's, those x and y are your variables now. You know the slope, you know that, and guess what we're going to do? Multiply both sides of this by the denominator, because I don't like the, I didn't say that, did I? Okay, sorry. Would I not like fractions? Okay, minus x1, and multiply this by x minus x1, and what do we have? These go away, and you have y minus y1 is equal to m times, get out of there, okay, x minus x1. That shouldn't be hard to remember. It goes straight out of the slope formula. Okay? So, with that in mind, we know what the point-slope formula is. Know a point, know a slope, here's the equation. All right. And again, just like before, you know a point. What point do you want to use? We used, what was it? We used 4, 0 last time. Let's use the other one this time just to see if we get a different equation. We might, you know, and then it would be really bothersome, wouldn't it? So this time we'll use, what is the other one, 1, 3? Okay, 1, 3. Let's use that point, and the slope is still minus 1, wasn't it? Okay? So, tell me what to write where. Help me, help me. Say again? Okay, I couldn't hear. Y, yeah, y minus 3, because y is the variable, y1 is the point, okay, is equal to negative 1 times x minus 1. Perfect. Now let's do the math. Oh, that sounds good, doesn't it? Y minus 3 is equal to, first distribute, negative x plus 1, and then we do what? What are we trying to isolate here? We're trying to isolate the y, because what's f of y? What's y? F of x, that's what we're looking for. So add 3 to both sides, and what do we get? Y, which is, what is y? In function speak, f of x. And that's equal to minus x plus 4. Same as we got before. It doesn't matter which point you choose, as long as it's on the line. Okay? So that's how they found what the equation was. We did it just by plugging in a point. You can do it either way. Whatever floats your boat. Okay? Whatever you understand the best. You understand anything the best. Okay? Please do. Okay? They're both perfectly legitimate. So what are we going to do? Plug in. Guess what? They used 3.13 also. Okay? They plugged it in and the slope, and that gave us y is equal to minus, they didn't show all their steps, so did they? Minus x plus 4, and that means f of x, which is what y is minus x plus 4. Same thing we got the other way, right? Any questions? Making sense? Okay, good. And here's a picture of it, okay? We know that it's going downhill. Why? Because the slope was negative 1, okay? And what does that mean? It goes down 1 for every 1 it goes to the right. Down 1 for every 1 to the right. Down 1 for every 1 to the right. And down 1 for every 1 to the right. If I drew a single together. That's what a slope of negative 1. Y-intercept, 0, 4. Happened to be on this one, the x-intercept was 4, 0. That's what they gave us, but that wasn't guaranteed that's going to be the same. The reason that's true is the slope is minus 1. Okay? There's the slope. You already knew a whole lot about it before you ever drew the graph. Okay, and by the way, if you haven't noticed, this guy loves graphs. So expect this, folks, on just about every test and quiz you'll ever see, there's always going to be at least one graph question. Can almost guarantee that. Maybe not everyone, but I can't think of one that doesn't have one on it. Okay? So, there are two special kinds of linear functions. One is called the constant function. We've already talked about that. What's true about a constant function? The what? It's going to be constant, meaning it's a horizontal line. Never changes. No matter what x you get, the y is always the constant. Okay? What can you tell me about that equation? The equation for that. Y is equal to b. Whatever it is, it's just going to be a constant value. In other words, the m is, slope is 0. It's not rising, it's not falling, it's 0. Okay, perfect. So there's a constant function, f of x equals c. Why did they choose c? I guess because of the word constant. I would have used b because it's mx plus b, right? Okay, but either anything you want to call it. It's just a letter, okay. It has a domain. What's the domain of that constant function? All real numbers. What's the range of that constant function? C. That's all. That's the only y value you'll ever have for that function. Single real number C. Okay, the graph is a horizontal line because the slope is 0 through the y-intercept. And that's the only value it ever has. Okay. Now, the second of these is the identity function. Now, what do you reckon they mean by that? The y is identically x, okay, and x is identically y. They're the same value, so f of x equals x. Y is equal to x. How does that look? Well, y is equal to x. Let's go back to that. Sorry, shouldn't have gone here. When y is equal to x, what's your slope? What's the coefficient here? 1. Okay. What's the x-intercept? 0. Okay. Now, if the x-intercept is 0, where does that function pass? The origin. Always at the origin. Anytime the y-intercept is 0, that line has to go through the origin. Also, x is 0, y is 0. Because f of x equals x. So x is 0, your f of x, which is y, is 0. Okay? So, slope of 1, intercept 0. There it is. What's the domain of that? All real numbers. The range? All real numbers. Slope of 1, y-intercept of 0, 0, always passes through the origin. The graph of the identity function is basically you would call this the positive diagonal, okay? Meaning it goes right through here. When x is 1, y is 1. When x is 2, y is 2. When x is 7,583,000, y is 7,583,000. Same value. X is negative 1, y is negative 1. X negative 2, y is negative 2. Every x value identical with the y value. We call it the identity function. Okay? And this one, what can you tell me about it? The increasing, decreasing, constant nature of it. Always, like delta, always climbing. No, always positive. Because the slope is 1, positive 1. So it's always an increasing function, forever. Okay. That, in many ways, is the parent function for most linear functions. Constant function, yeah, sort of, but the constant function doesn't always go through the origin. Okay. So that's why they get 2 on this one. All right, ready for next? Here's the next, the squaring function. That one's just simply f of x is equal to x squared. What are you going to do with that x? Remember your function, your black box, you turn the crank, it always squares whatever you put in. Okay? So you put in an x, it squares it. X squared, that's called the squaring function. Now, how does it look? Second? Parabola, exactly. Okay? What's the domain of that parabola? All real numbers. What's the range of that parabola? Only the positive numbers, because at x equals 0, f of x is 0. Every other x you put in there, positive or negative, you're squaring it. Squareds are always positive. So therefore, it never gets below 0, always positive. So from 0 to positive infinity. Okay? Okay, they say it's a U-shaped curve. We'll talk about that in a minute. I don't like them calling it U-shaped. I would rather they call it a rounded valley shape. Okay, but that they don't use those terms. Okay. What about the even and oddness of it? Even, because the only exponent is even, and whatever's happening on the right is happening on the left. Does the same thing on both sides. Even function. And what's its intercept? The x-intercept and the y-intercept exactly the same, 0, 0. Okay. We didn't say that about this one. What's the x and y-intercept are both 0, 0. Okay. Now, also, what can you say about its increasing, decreasing nature? For all negative x's, it's decreasing, and for all positive x's, it's increasing. So you would say that from x going from negative infinity to 0, it's decreasing, and from 0 to positive infinity, increasing. So you put each of those in parentheses. They look like ordered pairs, but they're not. Oh, there they did it. Good for them. Okay. Now, here's another. Is there any symmetry in that function? What's it symmetric about? The y-axis. Hey, guess what? That's what it means to be an even function. So if the function is even, it's symmetric about the y-axis. If it's symmetric about the y-axis, it's got to be even. And does this have a maximum or minimum? Minimum where? At the origin. You're exactly right. It goes up from there in both directions. Okay. And there is a graph of the squaring function. Now, it's a little U-shape-ish. I agree with that. except that a U usually straightens out, goes vertical. It doesn't. It always is moving outward. So that's why I called it a rounded valley function. It's eroded away in the valley, so it's rounded at the bottom. It just keeps heading up at the top. But books don't use that. Okay. Any questions on the squaring function? All right. Now we're going to look at three others. The cubic function, square root function, and reciprocal functions. Any idea what a cubic function might look like? It's a function, so f of x equal x cubed, okay? And then you're already drawing what it looks like. That's very good. So, here are some characteristics of it. What do you reckon the domain of the cubic function is? All real numbers, yeah. Oh, yeah, you know what? We probably do. Actually, we're not quite ready for the quiz, but guess what? If you want the weekend to work on it, hold on. Do you need graph paper?
No, I got some.
You got some? Okay, good. All right. We're not quite going to finish 1.6 today, but when we do, it's time for a quiz. So if you want to, we've done just about everything on it. It's just we got to finish this section, and that way you can work on it this weekend if you want to. Have an extra weekend to spend on it. Okay, what's the range of a cubic function? All real numbers as well. You read that, didn't you? Okay. Now, what about its even or oddness? It's odd because you put in a -1, it changes its sign. Okay? Exactly opposite. So it's an odd function. Okay? How about its increasing, decreasing nature? Increasing every, you're reading the book. Okay? You're increasing from the left, from negative infinity to 0, but also increasing from 0 to pi. So it's increasing of a whole real number range. How about, of course, the x-intercept and the y-intercept? Exactly the same, 0, 0. You plug in a 0, you get a 0. On the cubic function, by the way, did I say f of x equal x cubed? Okay? That's it. All right? Has it got any symmetry to it? Ooh, wow. Does it have any symmetry to it? Huh? Symmetric about the origin, because it does the same thing on the left as it does on the right, but in opposite directions. At any time it's an odd function, it's symmetric about the origin. Those two go hand in glove. Okay? Symmetric with respect to the origin. Graph is increasing everywhere. Here's how it looks, the cubic function. We've seen it before, I think, pretty sure, because we wondered, remember when we had it last time, we wondered if it was a constant somewhere in there, but it isn't. It's just changing very, very little. For a little change of x, you got a very little change of y, but it is always increasing everything. Okay? That's the cubic function. The parent function for all cubic functions. There it is. Okay. Any questions on that one? All right. Can anyone hazard a guess about what a square root function is going to look, how you would write it? Not draw it, write it. Square root function. F of x equal? Square root of x. Hey, y'all are pretty clever. That is the square root function. Okay? The parent function for all square root functions. Okay, can you tell me anything about its domain? Yes, you only can only put in positive numbers, because guess what? You can't take the square root of a negative number. So the domain is limited to only x is greater than or equal to 0. Okay? So if you put it in a bracket, 0, comma, positive infinity. Okay.
It always starts from the origin.
From the origin, exactly. Yeah. And the reason is you can't take the square root of a negative number. So its domain is only the positive numbers. And 0, count 0. Okay? How about the range? Now here's something sort of strange about the square root function. When you see this square root symbol, and that's all you see, that means the principal square root, principal same letter is positive. So guess what the range of this is? Only 0 to positive 30. Only positive y's of the basis. Okay? So the range is also non-negative real numbers. Okay? Now, does it have an intercept? This function. Does it have an intercept? What happens if you plug in that x equals 0? Y is 0. You plug in y equals 0, that's x equals 0. 0, 0 is both intercepts. Again, just about every one of them has been that so far. 0, 0. Okay? How about increasing or decreasing? It's increasing. You put in a larger x, the square root of a larger number is larger. So it's always increasing on its domain, which is 0 to positive infinity. Okay? Now, notice on the increasing and decreasing too, they always use parentheses. You don't worry about the endpoint, whether it's counted or not. Okay? If you're talking about the domain up here would be 0 to infinity, like that. The range would be 0 to infinity, like that. All right. Now this is a kind of a trickish kind of question, but it's one that I hope it gets you thinking. Is the fact that the domains this and the range that they're identical to each other, that they're the same. That's the problem with this notation. What does this mean? If it's the domain, these are what kind of values? X values. If it's the range, what values are those? Y values, okay. So yeah, even though they look like they're the same, these are the values for X, these are the values for Y. Domain is always the horizontal axis, and range is always the vertical axis. So just because they look the same, if you wrote them in set notation, that'd be the set of all x's such that x is greater than or equal to 0. This would be the set of all y's such that y is greater than or equal to 0. You'd see the difference there. You don't see it there, but it's still there. Okay. How about symmetry? There is none, because it starts at the origin. There's nothing on the other side. How about even or oddness? Neither. This is one of those neither functions, because it's neither even nor odd, because it only is defined on one side of the origin anyway. Okay. Here is a graph of it. What does that sort of look like? I don't know if you're familiar enough with shapes. What does that kind of look like? Say again? Part of actually more than an oval, and here will be a hint. Let's take this and let's rewrite this as y is equal to the square root of x. If I wanted to get rid of the square root sign, what would I do? Square both sides. That would make it y squared is equal to what's square root of x times square root of x? X. What does that shape? That's a parabola. So this is half of a sleeping parabola. It's lying down, so it's half of a sleeping parabola. The top half. Okay, never mind. Okay. Why is the bottom half not included? Huh? Okay, and now I'm not talking about here, I'm talking about down here. Why would we not include the bottom half of that parabola? Second? Okay. Ah, what? Fails the vertical line test, it wouldn't be a function if you included the bottom half. That's why it's only the top half of a sleeping parabola. Okay. So, all right, I got lost on where I was. Okay. If you're following the book, we're on page 62. I hadn't been flipping pages like I should have. Okay. Yeah, I think we have time for for the next one. Here is a reciprocal function. What does reciprocal mean? 1 over. You flip it, okay? The reciprocal function then would be 1 over x. All right. Now, I wish I didn't show all this stuff. Okay. What can you tell me? When you look at that function, what should pop into your mind one of the first things? That what? There's one thing that should pop into your mind right at the top. When you see that function. Has to do with domain. Is there any limit to your domain? It can't be 0. You can never divide by 0. Okay? So your domain has to exclude 0. Any other exclusions? No. It'll work for any negative number up to 0 but not counting 0, and any positive number starting at 0 but not counting 0 to positive infinity. So that's its domain. Negative infinity to 0 with a parenthesis because it can't include 0. Union that with 0 but with a parenthesis that it can't include 0. Positive infinity. Now, how about the range? What y values can it take on? Here's a hint. Okay? If you're looking for the y values, here is a function, 1 over x. Okay? Can that f of x ever be 0? What's going to make a fractional form equal 0? The numerator. If that numerator is not 0, no way that fraction will ever be 0. So guess what? The range of this also has to exclude 0. Exclude the origin. It's only positive values if x is positive, negative values if x is negative. So yeah, the range looks the same way, but those are y values, those are x values. What about the even and oddness of it? Why? Because it said it? Yeah, you read it in the book. Yeah, I see that. No, okay. He saw the picture in the book. But what the test is, put in a minus x here, right? What does that give you? Minus 1 over x, which is exactly the opposite. So that is indeed an odd function. Now, see, this is a polynomial function, so you can't go by exponents. And if you did, that would be x to the minus 1, but we haven't covered that yet, but that's what it would be. And then you say, well, that's sort of odd, isn't it? And it kind of is. Okay. So you could kind of do that, but it's only guaranteed for polynomial. Okay. Now, does it have any intercepts? Why not? We just said x can't be 0, and we just said that y can't be 0. So your x-intercepts are where y is equal to 0. Doesn't happen. Y-intercepts are where x equals 0. Doesn't happen. So therefore it has no intercepts. First one that wasn't 0, 0. Okay. Because it can't be that. Okay, how about increasing, decreasingness of it? Okay, what happens for positive x's? Give me an x that's positive. Any x is positive. 2, 5. Okay, let's take those two. 2 and 5. Let's do 1 over 2. What is that? 1/2. That's a fraction about here. What about 1 over 5? It's a little less, isn't it? So when you're increasing your x, you're decreasing f of x. Okay? That's on the from 0 to positive infinity. How about on the other side? How does that look? Let's take the minus 2 and minus 5. Minus 2 is less than minus 5. But what do you have when you put 1 over minus 2? Negative 1/2. 1 over minus 5 is negative 1/5. Again, it's decreasing. So it's decreasing on both intervals, 0, negative infinity to 0, and 0 to positive infinity, but they never touch. Never the twain do meet. Okay. Now, does it have any symmetry? If it's odd, it has to be about the origin. Symmetric about the origin. Those two things always are going to coincide. Oh no. Aren't we almost out of time? Let's see what the graph looks like first. Okay, there it is. See, it's decreasing function on the left, decreasing function on the left, decreasing function on the right. not defined at 0, 0, or any value for x equals 0 or y is equals 0. There are no intercepts. That's how it looks. And most of your reciprocal functions, and I'll say later we'll call them rational functions, a lot of them will look similar to this in some way or another. All right, we'll start next time with step and piecewise defined functions. Let me give you a few homework exercises. Either 11 or 13 or both. They're both at Calc Chat. 11's at Calc View. Any of the odds 15 to 25, they're all at Calc Chat. Whoa, they introduced a new function in there to you. So whoa, man. Let's stop at 20. Try it through 23, okay? We haven't done 25 yet, so try it through 23. All right, and what else is? It's quiz time, okay? And let me know whether you need graph paper or not. I don't know where those came from, but they'll work too, okay? You need graph paper? You don't. You need graph paper? There's only one to be graphed. You need graph paper? Okay. You need graph paper? You graph paper? Okay. You got some left over from last year. Okay. You graph paper? Okay. You graph paper? Okay. You need graph paper? Whoa! What? Throwing it on the floor, huh? All right. You grab paper? You grab paper? All right, everybody get one? Yes. All right, they're not due. No due date yet. It'll probably be a week from Tuesday, because we'll finish this section on Tuesday, and then you have a week after that. So this gives you 2 weekends for this one. Don't make those. Okay. What is that doing here? Oh, wait. Yeah. Okay, good. Got it. Okay, good. I panicked. I thought I was giving y'all the wrong test quiz. Okay. Good deal. Have a good weekend. Have a good weekend. Let me turn this off.